Good afternoon, grade 8. How are you today? This afternoon, we will talk about temperature and heat, and we will talk also about electricity. I know these topics are very familiar to you. Now, who can tell me what is the difference between temperature and heat? Okay, so as we go through this discussion, you can identify or you can differentiate between the two and also about electricity. When we say heat, it is the flow of energy due to temperature differences. And temperature depends on particle movement. All matter, all of the materials that you can see around you is made up of atoms, and they are constantly moving. Even solid objects have atoms that are vibrating. The motion from the atoms gives the object energy. We have the kinetic theory of matter. As what I've said, all the particles or atoms of a matter is constantly in motion. So we have here the four states of matter. We have the solid, vibrating atoms, the liquid, flowing atoms, the gas, it moves freely, and we have the plasma, which is very rare here in the world, and it can be seen in the outer space like the sun and the stars. It moves incredibly fast and freely. Always remember grade 8. So when an atom undergoes heating, it moves very fast. It will get energized. Okay? So we have the temperature. It is the measure of the average kinetic energy of all the particles in the object. The atom's mass and speed determine the temperature of the object. And we have the units for temperature. We have the degrees. So we have the 3 degrees Celsius, Fahrenheit, and the Kelvin. But the standard unit that we use is what we call Kelvin. So here we have the Fahrenheit. Water freezes with 32 degrees Fahrenheit. So when we convert Fahrenheit into Celsius, so it is 0 degrees Celsius. And it boils 212 degrees Fahrenheit. So when we convert it into the Celsius, it's have 100 degrees Celsius. 100, yes, degrees Celsius. So how does a thermometer work? Have you observed a thermometer? Have you used a thermometer? Okay, you observe that there's a liquid there inside, right? And that's what we call liquid mercury. So when you put the thermometer in the hot water, you can see that liquid inside will increase or will go upwards. Okay, because the atoms or the molecules of that liquid will get energized when it undergoes heating. That's why it expands and it increases. So why do you think some of the engineers or construction workers, they need to put gaps, like for example hollow blocks, or like in the bridge? Why do you think, like for example in this picture, why do you think there's a gap here? Okay, is it because of the term thermal expansion? So when we are talking about thermal, what comes into your mind? We are talking about heat. Okay, so all of the materials when it undergoes heating, it will expand. All gases, liquids, and most solids expand when their temperature increases. This is why bridges are built with short segments with small breaks to allow for expansion. So energy flows from warmer to cooler objects. That's why when you put a metal spoon in a hot cup of water, you observe later on that the spoon will get hotter. So as what I said, heat, it is the flow of energy from an object at a higher temperature to an object at a lower temperature. So we have here the thermal energy or kinetic energy. It is the total random kinetic energy of particles in an object. So what is the unit we use to measure heat? So we use calorie and joule. Okay, so 1 calorie is equals to 4.18 joules. And some substances change temperature more easily than the others. So, like for example, I have here hot water and a metal spoon. Which do you think a substance that will catch easily hotness? Okay, it is the metal spoon. Okay, it conducts heat easily, right? Unlike in the water that it needs time for it to boil. Okay, so meaning when it's a specific heat, it is the amount of energy required to raise the temperature. Okay, so in the metal spoon, it has a lower specific heat because it will conduct heat in a shorter time than the water that you need more time for it to conduct heat. Okay, so the specific heat of the water is higher, and the metal spoon, it has a lower specific heat. So we have here the three ways on how to transfer an energy as heat. So we have the conduction, convection, and radiation. Are you familiar with these three? Okay, so let's talk about conduction. So when we are talking about conduction, we are talking about the touching, okay, touching physically to materials that transfer energy easily. So best example for that is when you put metal spoon in a cup or hot cup of water. And also the good conductors are the metals. Very good. And we have the insulators. Examples for insulators. These are the materials that do not transfer energy easily. So examples for this are the rubbers and the plastics. Very good. And we have also convection. So when we are talking about convection, it is the movement of large numbers of particles in the same direction within a liquid or gas. So when we say convection, we are talking about transferring energy in a liquid or a gas. So always remember when the air is warm or hot, it will rise. Why? Because it will become less dense. So meaning it will become light. Okay? Unlike in the cold air, it will sink. It's because it is dense. Okay? That's what happened. Okay. And we have also the radiation. So when we are talking about radiation, it travels by electromagnetic waves. Like for example, I know you're very familiar with this one because we already discussed this. So the visible light, microwaves, and the infrared light. So radiation from the sun strikes the atoms in your body and transfers energy. Okay, so these are the summary or the difference between the three. So again, conduction transferred by direct contact, convection, of course, in gases and liquids, and for radiation, it transferred through an electromagnetic waves. So we will have the electricity. So in your grade 7, what have you learned about electricity? Okay, so we learn about circuit. So what are the components of a circuit? Connecting wires, load, or what we call battery, switch, source, or the bulb. Does somebody want to try and define the word electricity? Okay, what is electricity? So it is a form of energy made up of charges that can produce light, heat, or motion. That charge is what we call electrons. That's why it is called electricity. It is from the electrons. Okay, so we have the current. What is a current? It is a flow of electrons or individual negative charges. Again, The electrons have a mass, but it is very small. And when they move through the conductor, there are collisions that produce heat. Don't overconnect outlets because they could short circuit. Maybe it can create fire. Just like this one, your Christmas tree. Okay, so we're done with this. So this time in your activity, I want you to get an example there in your house. One example of conductor, another example for insulator. But do not get the live wire because it's dangerous. Remember when I say conductors, like the metals, the copper, if you have the copper wire, when I say insulator, like the rubber or the plastic. Go! Okay, very good. Very good, grade 8. Now, how does a battery work? So we have the electrochemical reaction. So the chemical reaction in the battery causes a buildup of electrons at the anode. So anode here in your battery, that is your negative charge. And the cathode, that is the positive charge of your battery. Okay? So electrons repel each other and try to go to a place with fewer electrons. So the electrolyte keeps the electrons from going straight from the anode to the cathode within the battery. So in this picture, how about this one? As you can see here, is this an insulator or conductor? Okay, that's a conductor. Very good. How about this one? Which is a conductor? Of course, this one, the copper wire. And the insulator here is the rubber. Very good. And there are two kinds of electric current. The direct current, or what we call DC, and the alternating current, or what we call AC. So what is the difference between the two? Okay. So when we say direct current, it is a flow of charge always in one direction. And the best example for DC is what we call batteries. Okay? And for the AC, or the alternating current, it is the flow of charge back and forth, changing its direction many times in 1 second. An example for this is the plugs and outlets used there at home. As you can see there, that's the movement of the AC. So what are the advantages of AC? Okay, you can control your voltage. You can raise it or you lower the voltage, and then more efficient over long distances. You can mostly in our house we use AC. Okay, because this is very dangerous to use. Note, many devices such as computers plug into the wall using the AC current, but the AC current is converted into DC current to run through the machine. Okay, for simplicity's sake in this activity, if it has a plug, we will call it AC. And if it doesn't, we call it DC. Ready? Okay, identify whether the picture is AC or DC. Okay, ready? Okay. Oh, here. How about that one? Is it AC or DC? Okay, very good. It's AC. This one. DC. This one. AC. How about this one? The car battery. It's the DC. How about this one? Oh, it's the AC. Very good. How about this one? Your cell phone. It's DC. How about that one? AC. Very good. How about that one? Okay, it's the AC. How about that one? AC, very good. How about your calculator? DC. AC, your flashlight, or it's laser. DC, how about that one? AC. Oh, there's two. This controller is what we call DC, and this one is your AC. How about that one, your electric fan? Okay, it's AC. How about that one? DC. Last one, your remote control. DC. Very good. All done. You've been thunderstruck. Okay, this one. Which is the AC? This first picture or the second? Okay, AC is the second. And the direct or the DC is the first picture. Very good, grade 8. Where do you find this strange device? Are you familiar with this one? Okay, this is what we call electric meter or energy meter. It is a device that measures the amount of electrical energy consumed by a resident, business, or an electrically powered device. Okay, so we have the term volt or voltage. It is a measure of the force or pressure under which electricity flows. And we have the term ampere. So when we are talking about ampere, we are talking about current or the electricity. Okay, it is a measure of how much current moves through a wire in 1 second. And the relationship between the voltage and the current is directly proportional. The more voltage it has, the more current will flow. Okay, again, the relationship between the voltage and the current is directly proportional. Remember that one, grade 8? Okay, basically, the larger the size of wire, the greater the current capacity or the greater the ampere capacity. Okay, so where do you see these plugs? Why are they larger? Why do you think so? Okay, the plug to a dryer or stove. So you can see this one in your stove or in your dryer. It is much thicker than a standard outlet to account for extra amps or to account for extra current. Okay, so we have the watt, the amount of electricity consumed per second. Watt, that is the unit for power. Okay, and it is calculated by multiplying volts times ampere. Okay, remember that one. Volts times ampere. So voltage times current. So most household electrical usage is billed in kilowatt hours or the amount of hours times 1,000 watts. So now I want you to get your calculator and try to solve this problem. So we have a small computer server with a sticker that shows 2.5 amperes. Given a normal 120 volts, 60 hertz power source and the ampere reading from equipment, how many watts does it require? Okay, raise your hand if you have no clue because you weren't paying attention for that black slide that discussed what a watt was. You're not paying attention, grade 8? Okay, you make sure you pay attention with this video because during our virtual class, I will have a short activity, computation activity before I will start reviewing the video. Okay, you try to solve. So this is the formula. Watts equals volts times ampere. So if the missing is watts, of course, you multiply volts and ampere. But when the missing is the ampere or the current, we just cover this one. You use the triangle thing method. Okay, you cover this one, then ampere equals watts divided by volts. So how many watts does it require? Okay, I will check that one during a virtual class. Okay, volts are a measure of the force or pressure under which electricity flows. Again, ohms are a measurement of the current flow rate of electrons, and watt is a measurement of electrical power created. Okay, which is the correct description of watts? Is it letter A, B, or C? It's very good. It's letter A. How about the amps? You're the current, the ampere. Okay, it's letter C. How about this one? The volts or the voltage. Okay, it's letter B. Very good. Now, it's still the same. We always memorize the formula for computing watts, voltage, and the ampere. Okay, we just covered. Now, what is a resistance? By just looking at this picture, what do you think the meaning of resistance? So when you search resistance in your English dictionary, it is the refusal to accept or comply with something. But when we are talking about resistance in a physics, okay, you can see this symbol. And that is what we call ohms, okay? It's O-H-M-S. The spelling is O-H-M-S. That is the unit for resistance. It is anything in an electrical circuit that impedes the flow of current, and it's referred to as a resistance. So earlier, I said that the relationship between the voltage and current is directly proportional. The greater the voltage, the greater the current will flow. Okay? So the relationship of resistance and the voltage, they are inversely proportional. So meaning, when the resistance is higher, the current or the voltage is lower. Okay, because they are inversely proportional. So always remember these terms. I give you 1 minute to read and to study this one. You can pause this video for you to take notes of the important terms. Okay, so this is the person who is responsible for the resistance. So he is George Simon Ohms, okay? Ohm found that there is a direct proportionality between voltage applied across a conductor and the resultant electric current, okay? So he is the one who proposed or discovered about resistance or the ohms. Okay? So the greater the ohm value, the more difficult it is for current to flow through a given circuit. So a low ohm value represents a low resistance and the easy flow of current through a circuit. That's the explanation of inversely proportional of the resistance and the current. Okay, so as you can see here, I represents, it is the capital I, not the small l. It is a capital I, and that represents current. Okay, why sure it's not letter C? Because C is already used for coulombs. For current, we use the capital I, and the unit for current is amps. Okay, equals voltage or the letter V, and your resistance, which has the unit of ohms, and this is the symbol. Okay. Remember the formula. You memorize the formula. So this time, I want you to practice solving this. So if 220 volts travel through a copper wire and the current is 36 amperes, what is the resistance of the wire? Oh, the resistance is missing. So what will you gonna do? So you need to cover the R here in the triangle. And then your formula is R equals V divided by I. Okay, you try solving there. Get your calculator. Okay, the answer is very good. It's 6.1 ohms. Don't forget the unit. Without the unit, it's a wrong. Okay. How about this one? A 9-volt battery supplies power to a cordless drill with a resistance of 18 ohms. So, how much current is flowing through the drill? The missing is the current or the capital I. What will be your formula? Okay. The answer is 0.5 ampere. Very good. Okay, try solving this one. A rude monkey that decided to stick his tongue to a 120 volts outlet with 50,000 ohms of resistance. How much current will he experience? Do you think he's still alive after doing that? Okay, the answer is, okay, 0.0024 ampere. Look what happened to the monkey. Okay, now about this one, a 110 volt outlet supplies power to a strobe light with a resistance of 2,600 ohms. How much current is flowing through the strobe light? Current is the missing here. So what will be your answer? Okay, the answer is 0.0423 amperes. Okay, very good. Grade 8. I hope you learned all about the computation of the voltage, the current, and the resistance. Now this time you get your notebook. I want you to write this one. You draw these symbols. Okay, so when you see this one, this symbol, meaning the switch is open. And when you see this one, the switch is closed. And this one, this symbol represents the cell. And this represents battery, the lamp, and the fuse. Okay, you can pause this video for you to copy these symbols. Okay, for your activity, I want you to research about what is the difference between parallel circuit and the series circuit. You need to send your answers in the Cerebro rather. You need to send your answers in the Cerebro. I will post their pre-recorded video answers, electricity. Okay? Again, you need to search about the difference between parallel and the series circuit. And that's all for this afternoon, grade 8. Thank you so much. Goodbye.